This lesson is on isotopes. Isotopes are atoms of the same element that have different numbers of neutrons. So if they're the same element, they always have the same number of protons, but neutrons can differ. If you have different neutrons, you're going to end up with different mass numbers. Because remember, the mass number equals the protons plus the neutrons. So if you're getting different neutrons, you'll have different mass numbers. Now, on the periodic table, you have the atomic mass or the atomic weight, and that's an average of all the isotopes, average of all the mass numbers. The reason it's a decimal is that it's a weighted average. What that means is it takes into account how many of each type of isotope you have. So, for instance, carbon has 3 main isotopes. Okay, so carbon always has 6 protons. That's its atomic number. But you can have carbon with 6 neutrons. You can have carbon with 7 neutrons. And you can have carbon with 8 neutrons. So when you add neutrons and protons, you get different mass numbers. So 6 neutrons, you have carbon 12. When you have 7 neutrons, 7 plus 6 is 13, so you have carbon 13. When you add 8 and 6, you get 14, so carbon 14. So these are 3 different isotopes for carbon. They have different properties. Carbon 14, for instance, is radioactive. This is used in carbon dating. So most of the carbon in the world is carbon 12. It's like 99 point some percent. Very, very, very little is carbon 14. But when you find a sample of carbon, for instance, the graphite in your pencil is carbon, you are made of carbon, every living organism has carbon in it, you have all 3 isotopes in that percentage that they exist in nature. So you essentially are radioactive, which is why we can use carbon for dating different things to figure out how old they are. So it's a weighted average, which we'll go through in class when we do our nuts and bolts team example. So let's go through a couple examples with iron here. So we've got 2 different isotopes. I know this because I see the mass numbers are different. We've got iron 56 and iron 55. So protons, we have to look at our periodic table. So I look up iron. I find its atomic number on your periodic table. It's the blue number, remember, in the upper left corner. It has 26. So both isotopes have 26 protons. Now, this one does not have a charge, so it's neutral, so it also has 26 electrons for both of them. Okay, but the neutrons are different because we have different isotopes. So in order to find the neutrons, we have to take our mass numbers. So for the first one, 56, and subtract our protons, 26. So 56 minus 26 gives us 30 neutrons. So we do the same for the iron 55. So we now have 55 as our mass number. So we subtract the protons, 26, and we get 29 neutrons. At this point, you should do the learning check, the practice problem in your packet, and type it into Moodle.